Hello everyone, welcome to my channel. If you are new to my channel, please subscribe to my YouTube channel, so you can join our tech family. If it is informative to you, please like our video, share it with your friends so they can get help with these video, and don't forget to press all notification bell icon so you get regular update and don't miss any single video.
So let's talk about antenna types. Some of you guys may be familiar with only one or two of these, and so I want to make sure you understand these. It's kind of funny, after you study wireless, it's amazing. You'll start looking around as you drive, and you'll start to see antennas that you never realized were there before, and they pop up in the strangest of places. So when it comes to antennas, it's kind of like that old saying, different strokes for different uses? Okay, yeah, because depending on what you're trying to accomplish will determine what type of antenna you want to use. Let's start with the traditional one that everybody knows about. It's called the omnidirectional antenna. You've all seen something that looks just like these, right? The big fat one there we usually see on the back of our access point. That first one there on the far left, that's actually a commercial grade access point that we typically install on top of a mast. Now with omnidirectional, it means that the signal is transmitted 360 degrees, and by default it's broadcasted out horizontally, meaning that our beam width starts at the antenna and moves in a horizontal direction. Now because it's broadcasting in 360 degrees, if you have certain amplitude on your antenna, you actually lose power. So an omnidirectional antenna is not as powerful as some of other types of antennas, and I'll show you why. Before I do that, I want to show you how an antenna is actually made, what's inside one of these things. And I'm going to demonstrate this by showing you just a picture of a pin. That would be the antenna itself, and inside it's going to have wire that's tightly wrapped around it. So from here, the signal would go out horizontally. If you wanted to have it go vertically, you would simply, this is actually a vertical polarized omnidirectional antenna. If you were to open it up, I had one of these and I opened it up and I was really frustrated because I paid a lot of money for it, thinking it was specially designed, and all they'd done is taken the coil and instead wrapped it this direction. Yeah, I paid like $300 for it. Really mad. Now, believe it or not, if these two antennas were on the same channel, because they're broadcasting their signal vertically and horizontally, there is technically 100 degrees of separation between them, and they won't have any interference. But again, a weaker signal. Then say, for example, a directional antenna. This is a commercial directional antenna. You'll notice it's flat. Inside you have the same concept as an omnidirectional, they just added something special. Now normally when you buy directional antennas, you have the option of buy them in various degrees, a 45, a 90, or 180 degree antenna. And they're more powerful than omnidirectionals because of this reason. Let's say this is a bird's eye view of the top of the antenna inside this particular antenna on the left. Well, we know that the signal will go out in a 360 degree pattern. Well, instead, if I take that antenna and encase it, all we have to do is put something in there that's highly reflective. Remember we talked about reflection earlier? Most of the time it's just sheet metal. And so that sheet metal takes the signal that hits it, and what ends up happening is when that signal hits that sheet metal, it actually reflects it and pushes behind the signal that's already going in that other direction and actually amplifies. It's actually kind of a cool concept when you think about it, something so simple. Now think about that for a second. A lot of times I have students ask me, Dale, what's the best way to deploy wireless in a work environment? Well, most of the time IT guys will go through and say, okay, I want to find my centralized location and I want to make sure I get the best signal, so I'm going to put it right smack in the center and let it broadcast out the signal, and that includes going all the way out to the parking lot where an attacker might be sitting and waiting or listening in. Instead, my own personal best practices is if my parking lot is on that north side of the building, I'll actually place my Wi-Fi access point in the corner. And by the way, I would also put my access points up inside of a drop ceiling or try to hide them so they can't be seen. So when someone's casing the joint, they don't know that there's an access point there. But up inside that plenum area, I would actually put a couple pieces of sheet metal up there so that what you just learned, the signal is going to get amplified and not overflow into the parking lot area. Now, obviously my signal is going to go stronger and therefore possibly even further to the bottom right-hand corner, and hopefully I don't have a parking lot there. But again, if I'm worried about it, I might put some sheet metal down in that corner as well, or just build my whole building out of sheet metal. I believe we refer to those as army barracks, right? We also have another type of antenna that's called a parabolic grid. This is what they look like. You may have seen these quite often. You have your transmitting element in the center there, and the grid portion is actually pushing as well as receiving, almost like a big satellite dish, receiving this signal and focusing it back to that center arm. Now these are more powerful than Omni antennas as well, and they're typically used for long distances like 10 plus miles. And back in my day, we actually had, this was a 25 dB parabolic grid antenna. We also had smaller ones that were 15 and 5. And to give you a better visual representation of what the grid is doing, this is a chart for that particular antenna showing you how the grid helps to focus, or they call it using directors to make the angle smaller, and therefore you get a higher amplification or a higher gain out of it. Another type of antenna that you might see out there is called a Yagi. This is what the Yagi looks like. Now, this is used for extremely focused connectivity. You cannot be with a parabolic antenna, you can be within a couple of degrees and pick up the signal, but with a Yagi, man, you got to be smack dead on. Again, huge distances for these particular types of antennas. And what happens here, or the mechanics of a Yagi, is this. The reason why they look so weird is that, first of all, you have what they refer to as the driven element. This is where the microwave signal comes up off the access point and starts to get pushed out onto the Yagi. This back pole here, this is referred to as the reflector, just like what we saw in the parabolic grid antenna. It's designed to push the signal back forward. And the reason why the bars up front are smaller, these are referred to as directors, is because it helps to focus that microwave wave. Can I say that? Microwave wave. I'll just shorten it up. It's there to focus that microwave so that it takes a smaller pattern and therefore is able to go longer distances and possibly pop more popcorn. And you think I'm kidding. So a real world story here. Back when I had my ISP and we were up on top of that really tall water tower, have I told you how much I hated that thing? I was actually up there once during a fog and ice storm. So I'm on top of the tower. It is so cold that the fog is turning to ice on the handrails and it's dark. So I can't see beyond the top of the water tower. I can't see my assistant down on the ground. And when it got cold like that, first of all, getting back down was really fun. It was a thrill of my life. But when it was winter and anytime it was cold, if your hands got cold up there or if your gloves got wet, you could just simply place them in front of the antenna and you'd get warm. Dale, that sounds dangerous. It really isn't, because even though it is a microwave technology, you have to think we're surrounded by this stuff and it's such a low frequency. It's not like putting your hands in a microwave oven. If it was, I would have taken a turkey up there with me and cooked a little dinner while I was up there.
We hope you enjoyed the video and found value in the content. We value your feedback. If you have any questions or suggestions, feel free to post them in the comments section or contact us directly via our social platforms. Thanks for watching.